Hello everybody, this is a lesson for Wednesday the 13th of January, further maths lesson, and it is a continuation of connected bodies, the chapter we were working through before Christmas. And the questions we were doing before Christmas were about cars towing a trailer, those two connected bodies, but now we are looking at pulleys, so another type of connected bodies, another system. So I'm going to look through, I'll talk you through the textbook example very quickly, and then what I'll do is I will talk you through questions 2, 4 and 6 of the exercise in the book, and I'll get you to try questions 1, 3, 5 and 7. So I'll talk you through this, then I'll talk you through 3 questions, and then you can try 3 questions. So this is the worked example. The question's on the left and the working out is on the right. So here's the bit of information. Now for all of these questions you have the information, but you don't have a diagram, so you will have to draw a sketch. So two bodies of mass 0.3 kilograms and 0.1 kilograms here and here are connected by a light inextensible string which passes over a smooth fixed pulley. So inextensible, the string isn't going to stretch out, and smooth, we don't need to worry about friction. Okay, now forget about looking at the questions just at the minute. They are 0.3 kilograms and 0.1 kilograms. So if we were to let the two bodies, if we were to release them, well then the heavier one is going to fall down, the lighter one is going to go up. So the 0.3 kilograms is going to go down towards the ground, and the 0.1 kilogram weight is going to go up towards the pulley. Which is why on our diagram here we have these arrows of direction. So the arrow of direction depends on, well, which one of the bodies weighs more. Now for all the questions in the exercise that I'm going to get you to do, we'll have 3 questions, A, B, C, and they're all the same questions. We're looking for the acceleration of the system, we're looking for the tension in the string, and we're looking for the force exerted by the string on the pulley when the bodies are in motion. So for the first question, part A, for all of these questions you're going to do F equals ma. And you're going to do that for each of the two bodies. So in this example you're doing F equals ma for the 0.3 kilograms and F equals ma for the 0.1 kilograms. So that will give us, we'll eventually get an answer for the acceleration. We'll then use that answer to work out the tension. And then part C is actually pretty straightforward. Part C is just an addition of the two tensions, and I'll talk you through that in just a little minute. Okay, so our diagram, the diagram we're going to use over here to solve the problem. Our diagram, like I said, we have our arrows, our directions of motion, depending on which of the weights is heavier. Each of the bodies will have a force acting down, and that is the weight of each body. Now remember, we were given the mass. Look, these are mass 0.3 kilograms and 0.1 kilograms, but we want the weight acting down. Remember that W is equal to mg. So what we do is we multiply the mass by g, the acceleration due to gravity, and remember that we use g to be 10 meters per second squared. So for all of these questions, and you've been using 10 for all of these questions, so we're going to have the weight acting downwards, W equals mg. So you're going to multiply 0.3 by 10 and 0.1 by 10. So rubbing this all out, can you see that 0.3 kilograms becomes 3 newtons because we're times them by 10. 0.1 kilograms becomes 1 newton because we're times them by 10. So those are the forces acting down due to gravity. There's also forces acting up against each of the bodies. So the force acting up against the 0.3 kilogram weight, or the 0.3 kilogram mass, is the tension in the string. And there's tension in the string in the other body as well, pulling upwards. So can you see that, if I just zoom in here, for this 0.3 kilogram body, we have two forces acting on it. we have 3 newtons pulling it down, and we have T pulling it up. For the 0.1 kilogram body, we have 2 forces acting on it. We have 1 newton pulling it down, and we have the tension acting in the opposite direction. So these are the forces we're going to use to get the resultant force, which we will then use for F equals ma. So just looking at our working out here, consider the 0.3 kilograms particle. So we'll rub this out, and we're looking at this particle. Using F equals ma, where F is the resultant force. So the resultant force is equal to mass times acceleration. This is the force acting downwards, and this is the force acting up. Now, how do I know if it's 3 minus t or t minus 3? Because we know the direction in which this body is going. It's going downwards, so the forward force is 3 and the backward force is t. So the resultant force, therefore, is 3 minus t. That's F. F is equal to the mass times the acceleration. So we have an equation there for the 0.3 kilograms particle. Let's do the same for the 0.1 kilogram particle. We have 2 forces T and 1 newton acting in opposite directions. Now it is being pulled up, so our resultant force is this T subtract 1. So that's why we have here for the 0.1 kilogram particle, the resultant force is T subtract 1. It's moving upwards with the force of T, and 1 is it working in the opposite direction. So that's the resultant force. It is equal to ma, mass times acceleration. We have 2 equations there. 1, 2, with T here and T here. If we add them together, because we have a minus T here and a plus T here, if we add the 2 equations together, then we can work out A. So there's equation 1. There's equation 2. Adding them together gets rid of these T's. 3 plus minus 1 is 2. 0.3a plus 0.1a is 0.4a. So divide 3 by 0.4. You get a is equal to 5 meters per second squared. So what is that we've just worked out? That's acceleration. Look at the question. We're looking for the acceleration of the system, which means the acceleration of this and the acceleration of this, they're both the same because they're connected. So we have the acceleration of both particles. Now what we're looking for is the tension in the string, and this is where we use these 2 equations, 1 and 2. We know the acceleration now, so we can sub it into either 1 or 2 to work out the tension. And that's what they're doing here. You can find the tension by substituting the acceleration, which is 5 meters per second squared, into either equation. So look, that acceleration is 5 meters per second squared, so we can sub it in and then get our value of t. Now that t is here and here. They're both the same. Okay? Now for part C, it asks you for the force exerted by the string on the pulley when the bodies are in motion. This is just 2 times the tension. The force exerted on the string, by the string on the pulley. So not only do we have tension acting up, we have tension pulling the pulley down. So for the answer for this question, you'll just add the 2 tensions. So whatever your answer was for part B, just multiply it by 2. And that's it. And that's how you answer all A, B, C for all of these questions in the exercise. So I will show you questions 2, 4 and 6 very quickly, and then you can do questions 1, 2, 3, and 1, 3, 5 and 7. And I've included the answers for you as well. If you're happy enough to go on and try questions 1, 3, 5 and 7, well then there's no need to watch the video. If after one of these questions you can pause and try the questions, then happy days. But the questions I want you to do are the odd questions 1, 3, 5 and 7, and they'll be in the attached PDF. So this is question 2. 2 bodies of mass 1.2 and 0.8 are connected by a light inextensible string which passes over a smooth fixed pulley. Exactly the same type of question. The system is released from rest with the bodies hanging vertically. Calculate the acceleration of the system, tension in the string, and the force exerted by the string on the pulley. Same three questions. Our diagram. We have our mass inside of the particles. We are given the mass, but we want the weight acting downwards. We get the weight by multiplying by 10. So our forces acting down are 12 newtons and 8 newtons. Look at the direction of travel of the two particles. The heavier one is going to go down and the lighter one is going to go up towards the pulley. So the two forces acting on the 1.2 kilogram body are 12 newtons acting down and T acting up. The two forces acting on the 0.8 kilogram body are T acting up and 8 newtons acting down. So take one at a time. The 1.2 kilogram particle, the heavier one, F, the resultant force. So this F is equal to the downward force, subtract the tension. So the downward force 12, subtract the tension, that's the resultant force. And that is equal to mass times acceleration. So we have our first equation. The 0.8 kilogram particle, the direction of travel is up. So our resultant force is going to be this T subtract 8. So T subtract 8 is equal to our F, and that is equal to MA. So we have two equations, 1 and 2, both with one unknown, that is T. Add the two equations together. 1 plus 2, these go away. So then you have 12, add minus 8 gives us 4. 1.2a plus 0.8a gives us 2a. So the acceleration of each particle, therefore of the whole system, is 2 meters per second squared. Next thing we're asked for is the tension in the string. And look, we can use either of these equations to work out the tension because we know the acceleration now. So it doesn't matter which one you pick. If you sub in the acceleration, you will get the tension. So I have chosen equation 2. T minus 8 is 0.8a, but now we know what a is. A is 2 meters per second. So plug it all in. T is 9.6. The force exerted by the string on the pulley when the bodies are in motion, this is equal to the sum of the two tensions. So the two tensions are pulling down on the pulley. So you just double your tensions. 9.6 plus 9.6. And there's our answer. So our three answers are, the acceleration is 2 meters per second squared. Tension is 9.6 newtons. And the force exerted on the pulley is 19.2 newtons. Question 4. Identical type equation. 0.6 and 0.5 connected by a string on a smooth pulley. So there's 0.7, 0.5. Look at the direction. The heavier one goes down, the lighter one goes up. 7 newtons acting down, tension acting up. So this is where our F equals MA comes from in the 0.7. We have 7 subtract T as our resultant force is equal to MA. That's our first equation. Then we have, because the 0.5 kilogram particle is moving upwards, it's going to be T subtract 5. So T subtract 5 is our resultant force, and that is equal to MA. Two equations, add them together, you'll work out your acceleration. Substitute in your acceleration into either 1 or 2. Here I've subbed it into equation 1. So 7 minus T is 0.7a, but we know A. So work out T. T is 5.83. Part C, the force exerted by the string is just 2 times the tension, which is 11.66 newtons. So B and C, pretty straightforward. Part A, two equations, F equals MA, let them equal. Add them together. The last one I'll show you, exactly the same. 1.1, 0.5. Heavier one goes down, lighter one goes up. 11 newtons down, T up, 5 down. So for the heavier particle, 1.1, it's going to be downward force subtract tension is equal to 1.1a. For the lighter particle, it's going to be the tension subtract downward force is equal to 0.5a. Add our two equations together, and you get A is equal to 3.75. Sub it into our either equation that has tension and acceleration, you get 6.875 for tension, and times it by 2, you'll get the total force exerted on the pulley. So those are 3 questions. 2, 4, 6. Have a go at 1, 3, 5 and 7. There's the answers. I'm not getting you to submit anything, just try and get those answers, and if you have any problems, let me know.